Arizona's data center boom, energy challenges, and future solutions. Arizona is rapidly transforming into a central hub for data centers, sparking a significant surge in energy demand that has caught the attention of the state's largest utilities. These utilities, including Arizona Public Service Company and the Salt River Project, are now grappling with a potential tripling of energy consumption due to the influx of data centers. This burgeoning demand stems from Arizona's attractive operating costs, robust infrastructure, and the escalating need for computing services driven by advancements in technology like artificial intelligence. But here's where it gets controversial. The massive energy requirements of these data centers could lead to increased costs for existing utility customers unless new financial strategies are implemented. Data centers, which operate non-stop and house equipment that not only consumes vast amounts of electricity, but also generates considerable heat, require intensive cooling systems that further strain energy resources. In response, utilities are considering innovative rate designs and infrastructure cost recovery methods to manage the increased load without unfairly burdening current customers. For instance, APS has proposed new contract provisions specifically for data centers that include strict financial protection terms and minimum bill requirements to prevent cost shifts to other customers. And this is the part most people miss. The implications of these developments extend beyond just financial impacts. Local communities have expressed concerns about resource depletion, particularly in Pima County, where a large data center project has sparked fears of significant water and energy drain, potentially leading to higher utility rates. The debate intensifies as stakeholders, including data center operators, argue for fair contributions to infrastructure costs while demanding reliable service from utilities. The Arizona Corporation Commission is actively engaging in discussions to possibly create more transparent rates for data center customers, which could set a precedent for how utilities nationwide address the needs of large energy consumers. As we delve deeper into this issue, one must wonder, will the proposed solutions adequately balance the needs of all parties involved, or will they lead to greater disparities in utility costs? How will these decisions impact Arizona's attractiveness as a tech hub in the long run? I invite you to share your thoughts and join the conversation on this pressing issue. The new chips designed to solve AI's energy problem. Imagine a future where the very technology designed to propel humanity forward is held back by an insatiable hunger for energy. This is the stark reality facing the development of AI supercomputers, and it's a challenge that has left even seasoned experts like Andrew Wee scratching their heads. With over 30 years of experience in Silicon Valley, working with giants like Apple and Meta, and now leading hardware at Cloudflare, Wee is no stranger to the intricacies of data centers and hardware. Yet, the projected power demands of future AI systems have him, in his own words, befuddled and even irate. But here's where it gets really concerning. The World Economic Forum estimates that the energy required for AI will grow by a staggering 50% annually through 2030, a rate that we and many others believe is simply unsustainable. And this is the part most people miss. The current pace of energy consumption by AI is not just a minor issue to be tweaked, but a fundamental problem that threatens to derail the entire AI revolution. But what if we told you that there's a glimmer of hope on the horizon? A new generation of chips designed specifically to tackle AI's energy problem is in the works, promising to revolutionize the way we power our AI systems. These innovative chips are engineered to be far more energy efficient than their predecessors, using novel architectures and materials to minimize power consumption while maximizing performance. For instance, some of these chips employ advanced techniques like neuromorphic computing, which mimics the human brain's efficient processing of information, or photonic interconnects, which use light to transfer data at incredibly high speeds and low energies. But here's the million-dollar question. Can these new chips really solve AI's energy crisis, or are they just a drop in the bucket? We and other experts argue that while these advancements are crucial, they are only part of the solution. The real challenge lies in fundamentally rethinking how we design and deploy AI systems, from the software and algorithms used to the data centers that house them. So we have to ask, Are we on the cusp of an AI energy revolution? Or are we just delaying the inevitable? What do you think? Should we prioritize the development of more energy-efficient AI chips? Or do we need a more radical overhaul of our approach to AI? Let us know in the comments. The future of AI hangs in the balance, and it's time to spark a conversation about the energy crisis that could make or break this technology.